So here's my path. So previously, I had some trees, I had some regressions, and I also had some problem. Previously I had a best decision tree that had performed poorly, that didn't have the highest level of accuracy, even if it's a best decision tree or classification tree. Later on, I fixed that. I think it's behaving weirdly. It didn't grow the way that I hoped it to grow. It grew a very narrow tree with 5 levels. That's why its performance was bad. So but I couldn't pinpoint which setting led to that change. So I ended up deleting that tree and retraining another classification tree, and that worked. So right now, my models look like this. By using the validation set misclassification rate, my best model is the stepwise regression model following the impute node. And then my best classification tree, which didn't use the imputed data, directly feed from the partition, it has the second best performance here. And the maximal tree and the full regression model that includes every variable in the regression perform equally poor here. So I'm quite happy with the result. So what I'm going to do is to do a neural network and to see how that compares with these models. And you can kind of refer to the notes here. Because neural networks can't deal with missing values by itself, so we need to put it somewhere after the impute node. Sometimes it's better if you have other replacement nodes before impute node, but here I'm going to skip that. But either way, it's a fair comparison here because the almost same treatment to the data. So let's see. Let's have a manual neural network. Here, and three factors that you can manage about the complexity of the model. Let's see. The network in a network property, you can control the number of hidden units. The range is 1 to 64, which is more than sufficient in most cases. And so this is one factor that you can change, is the network, which controls the topology. And I think for now I can change it to 5. Let's see. And the second factor to change is the optimization process. The optimization process, you can modify modify the number of maximal training steps. So this is the number of training steps. For this data set, even if you train 200 times, it won't stop. It won't be sufficiently enough to have a perfect model. The goal is to have a perfect model for the training step, but the selection step is a different process, right? So even if you have 200 steps, it won't reach a saturated model. But I'll use 100 for now, and let's see. Maximum number of time you can limit. And there's a preliminary training process. I think in the guide, it asks you to turn it off. I'll just leave it on. to save some time. Question?
Professor, is there maybe listed some documentation on some kind of like a hotkey code to a board if it's running for 4 hours? Like an escape or
Yeah. Here.
Something there. Control C.
Stop run.
You can do that.
Yeah, you can do that once it runs. Yeah, I was there. Yeah. And you need to make sure you change the model selection criteria. And for comparison, I'm changing to misclassification because for model comparison, I was using the misclassification. And that's it. Continue training is a setting where you can run it one time for 50 or 100 steps, and then do it one more time and train the model based on what you have. So keep training instead of going from scratch. But since I'm going to train for just once here, so that doesn't matter. Score. So I can run it, and let's take a look at the result. And I think, so let me demonstrate if that works. This work. There's one thing I forget to point out is the normalization of, I think it would be under optimization. Non-linear options. It's not here. Somewhere. Network. So there is an input standardization option here. Either range or standard deviation would be similar, if not the same. There's not really a hard rule that you have to go one or the other. So you can try both and try two different models with different options to see the impact. I'm going to leave the default. And now we can train it. Okay, so the neural network didn't perform as well as the other two, the stepwise regression and the best classification tree. The difference with the tree is not big. The difference with the regression is quite big in this case. There may be different factors that went into play. Let's see. I don't have more time to. So next time I'll show you how to. At this point you don't know how many input neurons there. You need to figure that out to answer the question. When you look at the results, you can see there's a way to figure out. Next time I'll demo. Let's look at one thing here. Is the overfitting chart. It's here. So the x axis is the number of training steps. The blue line is a training set. As it keeps training, it typically improves the performance there, right? But after only a few steps, the red line keeps climbing. It starts climbing. That's when the model is becoming too complex in some extent. So it doesn't even have to go to 50 steps before, all the other models are not going to be selected because they are overfitting. This is overfitting by a big margin. So what is going on here? There may be different factors, different ways that you can, maneuver and try to improve, and that's what we're going to talk about next time. Any other questions about neural networks? So I'll post the grades before next week, right? And next class, you can see the feedback. I'll post the feedback somewhere online, and then it will be secure. It will be private, so each of you can look at by using your own credential. Any other questions? So have a great weekend. No homework?